Okay, so on average, these questions are very obvious. Average number of emergency call. Number of emergency call already sound like is discrete. Then they say average some more. Then we know this is Poisson. X is number of emergency call. So X distributed Poisson on average in a day is 2 call. So in a day. So lambda 2 call. So this one is for a day. So for the first question A, find the probability in certain day. Yes, we are doing a day. So how many emergency call they want here? Exactly 5 emergency call. So they're still in a situation a day. They want to find the probability. We have 5 emergency call. So from here we can use our formula, our Poisson formula. E negative lambda, lambda power questions, then questions factorial. So that will be our part A. Then we go for part B. What's the questions here? Part B. Find the probability in a certain day. Yes, still in the same time frame. They want less than 2 emergency call. So still in the same time frame, still in the same distribution lambda here, but the situation now is finding the number of call less than 2. In order to read table, here will be 1 minus more than 2. So read our Poisson table here. Lambda is 2, so we read for the reading 2. Lambda is 2, reading 2, 5940. Okay, so that is our question B. Question C. In a certain week, so original and we are doing the time frame is a day. So they come to a certain week. So there are 10 or more emergency call received. Then an extra team of firemen is required. So the probability getting an extra team is 0.89. So we fix our time frame first. Original is talking about a day, so it comes to a week, so our distribution will be different already. So X distributed Poisson when a day is 2, so for a week you need to times 7, so it becomes 14. So the situation here is saying if you have 10 or more emergency call, they will call for another extra team of firemen. Ask you to show to get this extra team of the firemen is 0.89. So what we need to find here is probability to get the number of emergency call 10 or more. So we have to get the number of emergency call label or sama dengan 10 supaya dia akan panggil lagi satu extra team ini. So apa yang kita nak tunjuk ialah extra team ini kita akan dapat probability 8906. Untuk distribution ini kita boleh rujuk terus kepada table. So rujuklah table lambda 14. Muka surat 15 ni. 10 ke atas. So you punya probability adalah 8906 shown. Okay, so we continue to the question. They say hence. So we have to be careful. Hence means refer to the result here. So you say in the 5 weeks chosen. So this is 1 week. 14. For the 5 week chosen, there are 2 weeks. So we are changed already. We are not talking about number of call. Now it's talking about weeks. Within the 5 weeks, we have 2 weeks. There were extra team of firemen is required. So this is our situation. This is our new situation. Our sample is 5 weeks. We check for 2 weeks where the situation is extra team of firemen is required. N is equals to 5. The probability to get extra team of firemen. Y is no longer call already. X is call, so Y is number of week where our team of the firemen is required. So Y distributed binomial out of 5, situation is 890. So out of 5 weeks, there are exactly 2. So the question here, daripada 5 minggu, you nak cari 2 minggu saja. So Y equals to 2. So 5C2 P power to 2. So Q, in order to get Q, it will be 1 minus 0.8906. So it gives you 0.1094. So here will be power of 3. Okay, and CR, P power of R, Q power of N minus R. Okay, so continue. C2, original is 5 weeks. Now they change question 100 weeks, by at least 85 weeks. Still same situation, extra trim of the fireman is needed, is required. So our Y here for question 2, our Y here is distributed binomial, now is 100. So as we see our binomial sample here, N more than 50 already. So we try to check. First condition, N is more than 50. So secondly, we seek for mean. So when we do the mean, we will notice that the mean is 89.06. So the mean also very high. So number 2, the mean is more than 5. So already fulfill second situation. And the probability is between 0.1 and 9. So this is the requirement for us to change the binomial to normal. So in order to change binomial to normal, we need mean and variance. So I have to continue find variance and PQ. So Q is 0.1094. So use your calculator, 9.74. Done the distribution only. Y become normal. So the distribution now become normal. Then we continue. What's the question they ask? You need at least more than 85. So this status is come from binomial. So we need to do normal. Then only you change to Z. You draw and you find from the table to get answer. So that will be our flow. Start from binomial because question is starting from binomial, which is not suitable, then we change to the suitable distribution, which is normal. So from binomial, from discrete random variable, when we want to change to normal, we need to do CC. So we have to add boundary on this. We have to make it become continuous random variable. So more than equal 85 means 85 is needed. After CC, it will be more than 84.5. Then we want to change to standard normal. So it becomes Z. 84.5 minus mean over standard deviation, square root of 974. So in the distribution here is variance. For finding the Z score is using standard deviation. You need to square root. So the Z value here, negative 1.46. We draw negative at left hand side, more than 1. So this is a huge area. So in order to find this area, from table 1 minus echo negative 1.46. So tak ada echo negatif, kita akan rujuk bacaan positif saja. So for normal 1.40, 1, 2, 3, 4, 5, 6. So this is 7 to 1.